Hi, I'm Charlie with Berd, and today we're going to go over the basic TRUDI application operation. The first step after getting the system on is to connect to Wi-Fi. We'll do that by swiping from the bottom of the screen, pressing the settings icon, and then selecting the Wi-Fi on the left-hand side of the screen. At this point, we can connect to our local Wi-Fi network before opening the TRUDI application. Now, we'll click on the TRUDI application at the bottom of the screen, which should open the application like this. At this point, the application should be fully functional. However, I want to show you the process for resetting the application. I'm doing a full electronic reset, whether or not you need to do that now or at any point in the future. The process for doing this is to first swipe up from the bottom of the screen, press the menu icon, and then swipe the application to close it. Now, we'll grab the power brick and we'll disconnect the AC plug, wait for 3 seconds, and then reconnect the AC plug. It's very important that we never disconnect the barrel jack from the back of the machine. Rather, if we ever need to disconnect the power, do that from the AC side of the power adapter. Now we'll see that the application has powered up, and we'll press the TRUDI logo and then see that at the bottom of the screen, the USB light has turned green. That means that everything is connected and it's ready to go. Now the first step, once we're into the application, is to log in. We'll press the menu we'll press the menu button at the top of the screen. We'll press login and type in our email address. Next, we'll put in our first and last name. And we'll create a password. Then we'll click Save. Be sure to keep this password in a safe location. Now that we're logged into the machine, we'll start by configuring our wheel type. For this example, I'm going to use a carbon rim. I'm going to select carbon from the dropdown with Sapim CX Ray spokes, which are bladed 0.9 millimeter spoke, a 29-inch rim, and 28 spokes. I'll click Select to pick that wheel option. Since this is a brand new wheel, I'm going to reset any previous measurements in the system. The second step of the configuration is to select the parameters for truing the wheel. So I'm going to click the button in the center of the screen to set the targets. With this, we can see we have targets for dish, lateral, radial, the high side tension average, our specifications for the maximum and minimum percentages for the high side tension average, and our specifications for the range of the tensions on the left and the right side of the wheel. If I'd like to change any of these, now is the time to do that. I'm going to change our high side tension to 110 kilograms of force and press confirm. Now that I have the wheel configured in TRUDI, I'm going to take our wheel and put it into the machine. The wheel always starts with the high tension side on the left. I'm going to take the high tension side with the left and put it within the gas spring. It's important that I be sure that the wheel is firmly seated within the hub mounting cones of the gas spring. The next step is to take the rubber band indicator. In this case, I'm going to use the short rubber band indicator because this is a shallow rim. I'll put this in the valve hole and wrap it around the rim, making sure that the rubber band isn't twisted and placed squarely on the rim. The next step of this process is to make sure that the gauges are adjusted properly. I want the radial gauge to be adjusted with the spring halfway in its stroke. So I can move this up and down to get it halfway compressed, and then I'll gently tighten the lever on the left side. Now I'll do the same thing with the lateral gauge to make sure the lateral gauge is again halfway compressed within the stroke of its spring, and I'll gently tighten the lever. Not much force is needed on these levers. It's just to keep the position in place. Now I've got the wheel correctly placed in the machine, and we'll go over some of the basic functions of the application. The new button on the top of the application resets the measurements to start a new wheel. We haven't done anything yet, but I'm going to just press the reset button here anyways. At this point, we can see that the dish button, which is the flashing button on the left-hand side of the screen, is the first button that we'll press to measure the dish, the wheel. We're then going to go through the sequence of first measuring dish, then measuring the lateral and the radial, measuring the tension, and finally truing the wheel, going from top to bottom and left to right on the screen. So I'll press the dish button first, and the wheel will rotate and do 2 full revolutions to take a left side measurement of the wheel and measure dish.
Measurement complete.
We'll move the advancement roller down. We'll flip the wheel. Again, make sure it's fully seated in the system. Move the advancement motor back up, and now we'll take a lateral measurement.
Measurement complete.
With both measurements taken, we now have a dish value, a lateral runout, and a radial runout. And those 3 measurements are shown on the top of the circle, with the leftmost measurement being the dish. So this wheel is 0.11 millimeters out of dish center. The lateral runout is 0.54 millimeters, and the radial runout is 0.26 millimeters. The next step of the process is to measure tension. The button on the bottom of the screen is red because it automatically went into tension mode. When we measure tension, we'll move the advancement motor down, and we'll put the tensiometer on the first right side spoke. We always start the tension measurements on the first right side spoke, which is spoke number 2. And then we move around the wheel by pushing the wheel downwards to measure all of the even spokes. The spoke number is displayed in the center of the screen, and each tension
Move to first left side spoke.
shows up in that center. After measuring all the spokes on the right side of the wheel, it prompts us to move to the left side of the wheel. These are all the odd spokes. And so we see the numbers starting at 1, going through all the odd numbers until we get to spoke number 27.
Measurement complete.
I'm not going to go through the full details about how to use the tensiometer in this video. We'll show that in another video, teaching you how to both be efficient with it and get accurate data. Now that I have the lateral, the radial, the dish data, and our tension data, the system automatically calculates how many turns to do on each spoke to both true this wheel and bring it up to the desired high side tension, which in our case was 110 kilograms that we entered into the configuration before we started. On the bottom of the screen, we see 3 more data fields that have now populated with tension data. So at the very bottom, we see the high side tension average, which is 80 kilograms of force, which means we have 80 kilograms of tension on the right side of the wheel. Just to the left of that, we see a number of 8.1 kilograms, which is the variation in tension on the left side of the wheel. And on the right side of that, we see 4.8 kilograms, which is the variation in tension on the right side of this wheel. In the center of the wheel, though, we see where the magic has happened, where the system has calculated how many turns to do on each spoke so that we can now go around the wheel and true the wheel in a single pass with a drill. I'm not going to show the truing process in this video, but we do have use cases where we'll show truing many different types of wheels in separate videos. We also see the undo and the redo buttons on this screen on the left and the right, and that gives you the ability to either undo a spoke that you did if you made a mistake with the drill, or redo a spoke if, for example, you press the trigger while the system was not on the correct spoke. What I'm going to do now is show you how we can see more data than just what's shown on this screen. So if we press the graph icon in the upper left-hand side of the screen, we can now see the charts for the lateral on the top, the radial, which is the second graph from the top, the left side tension, which is the third graph, the right side tension, which is the fourth graph, and then finally the graph on the bottom shows the number of turns calculated that the system's going to perform on each spoke as we true the wheel. We can also cycle between the different truing methods. With the green button illuminated on the bottom, the system right now is in the full true mode, but we can press that button to cycle between full true, quick dish, and quick true. We won't talk in detail in this video about what these different methods do, but as we click that button, we can see the data in that bottom graph change, because these are all different methods of truing, which are going to give different numbers of turns on the spokes, depending on what we want to do in truing this wheel. I'm going to press the home button now to go back to the home page of the screen and just show a couple more features on the application. At the very bottom of the screen, it shows us our tension target, and that's just a good reminder so that we can remember what we've set that value to when we configured this wheel in the first place. It also shows the average turns. So if we cycle back to the full true mode, it says we're going to do an average number of turns of 0.55 turns on the left side of the wheel and 0.75 turns on the right side of the wheel. And we don't need to look at those numbers, but they're just good indicators if we want to be able to see roughly what we're doing before we put the drill on the spokes and true the wheel. The other thing that we see at the bottom of the screen is the manual drill mode. So if I take the system out of full true mode, first I can click the manual drill button, and to do that, I'm going to press the TRUDI logo at the top of the screen. Now the number of turns have disappeared in the center of the screen. I'll press the manual drill button, and it immediately is set up to move a quarter of a turn. So if I press the button, it'll turn positive by a quarter turn. If I press the plus button, it'll change from positive turns to negative turns. So it'll go negative a quarter. And now I can adjust this to any value I'd like, but I have some quick presets, including 4 turns, which will do 4 turns on the drill. Those functions can be useful for bringing up the tension of a new wheel, or other aspects such as replacing a broken spoke on a wheel. The last basic function I'll show on the system is the save button. Because I've gone into the manual drill mode, it's cleared all of the data from the system, which means it thinks that I've trued the wheel and there's no data left to be able to save. So that save button on the top has now turned from green to being grayed out. But if I had just taken the data for a wheel and I'd finished the measurements, I can press the save button and then enter in some information about that wheel and confirm, and that'll put the data into the database that I can then access at a later time. With that, I've shown the basic operation of the TRUDI application, and in future videos, we'll talk about use cases for both building and for truing wheels.